Let's do a box problem. For this problem, we want to maximize the volume of a box with a square base and a surface area of exactly 108 square inches. Now, in this case, this is an open box, and so we have a bottom, but we don't have a top. The first thing I want you to do is givens. So write down everything you're given in the problem. I already have my diagram, so I'm good. Now look at this. I have a surface area of exactly 108 square inches. So I know S is 108. Now, what is my unknown? What am I looking for? I'm being told to maximize the volume of the box. So I want the volume maximized. Now this tells me what I'm going to have to take the derivative of. E is equation. Now what's the volume of a box? Well, the volume of a box is the area of the base times the height. So for this one, it is x squared times h. Now, I can't just take the derivative of this. I know I need a secondary equation. So now I need to find my secondary equation, and that is given to me. The hint is right up here. The surface area is 108. So I know the surface area of this box, well, it's going to be the area of the bottom, which is x squared, plus the area of each side. Now, because the base is a square, all of these sides are going to be the same. And it's h times x. Now, for s, I need to do some solving here. I need to get the volume in terms of one variable, and I can pick either x or h. Now, let's look at this. I cannot solve this for x explicitly very easily, so I'm going to solve it for h. And it turns out that h is equal to, and I'm just going to do this in my head, s minus x squared divided by 4x. So now I'm going to take this right here, and let me change pen colors, and I'm going to plug it into my volume equation. So now my volume equation is x squared times h, and h is a little bit of a mess. Now, do you see how I'm leaving that s in there? You can do that, or you can change it up and put in the 108. At this point in time, you want to go in and simplify. So the volume is x times, how about x over 4, times s minus x squared. Now, I'm going to go and put s in here so I can simplify this equation down a little bit. So when I put in s, and I could have done that before, I get that the volume equation, when I simplify it, is 27x minus x cubed over 4. You want to make this equation as simple as you can because you have to take the derivative of it. Now, the next thing we need to do is determine what is a possible, what would make a reasonable answer? What would be a reasonable domain? Well, you know that x has to be positive, all right? So it can't be 0 and it can't be negative. Now, what's the area of the base? The area of the base is at most 108, all right? And if that's x squared, that means x has to be at most, so it has to be less than or equal to the square root of 108. So if I get that x is the square root of 1,000, then I know I've made a mistake. We'll use this to check at the end. Now, next step, solution. All right. To do optimization problems, you need to take the derivative of this equation and set it equal to 0. So dv dx is equal to 27 minus 3/4 x squared. And then you set it equal to 0. When I solve this, I get 27 is 3/4 x squared, which tells me that x squared is 36, or x is plus or minus 6. So since I know my domain is restricted between 0 and the square root of 108, I get that x equals 6 is the correct answer. But I'm not done, because in these problems in general you have to go back and solve everything else. If x is 6, all right, you have the surface area. A lot of times you're going to need to find the height. So the height is 108 minus 36 divided by 4 times 6. So h in this case is equal to 3. And now let's find the volume. The volume, I'm just going to go back to this equation up here, is 6 squared times 3, which in this case is 108. Interesting. Now the last thing we need to do is to check our endpoints, because remember, when we do maximum min problems, I'm trying to extend my page here. Let's first, we've already checked the volume at x equals 6. Now let's check the volume at 0. Well, the volume at 0 is 0. And the volume at the other end, at the square root of 108, is also 0. So this obviously is a maximum volume. And the dimensions are 3 by 3 by 6 inches.